second lecture of Chapter 2. This chapter is on conversion factors. And this lecture is going to pick up where we left off from the last one. Last time we were talking about equalities, which are ways of relating two things that mean the same, like 7 days and 1 week, or 60 seconds and 1 minute, 12 inches and 1 foot. Those are all the same way, the same value, right? It's different ways of talking about the same thing. And those are equalities. So today we're going to take our equalities and we are going to write conversion factors, which will allow us to convert between units. So here's an equality. 60 minutes equals 1 hour. And so we can write two different conversion factors for this equality. So the way that we write our conversion factors is that when things are equal, they get stacked. So in one conversion factor, we can put 60 minutes on the top and 1 hour on the bottom. And in another conversion factor, we can put 1 hour on the top and 60 minutes on the bottom. We can always write two conversion factors for each equality. And the way that we read these conversion factors is it would be 60 minutes per 1 hour, or 1 hour per 60 minutes. That line means per, essentially, and the per in our calculations will mean divide. Okay, so for each one of these, or for each equality, we can always write two conversion factors. In one instance, one half will go on the top and the other half will go on the bottom. And then for the next one, the other half will go on the top, the other half will go on the bottom. So we can do this for anything. So here we have 1 meter equals 100 centimeters. That is our equality, right? When they're equal, that's an equality. And then when we start writing them on top of each other, that's when we call it a conversion factor. And so in one conversion factor, we can put 100 centimeters on the top and 1 meter on the bottom. And in the next one, we can just flip it upside down. We can put 1 meter on the top and 100 centimeters on the bottom. So for every equality, we can always write two conversion factors. So go ahead, find your Chapter 9 lecture worksheet, or sorry, Chapter 2 lecture worksheet, and complete problem number 9 to get a little more practice doing these conversion factors. Once you're done, come back and we can move forward. Okay, so now we can use these conversion factors to actually go about solving problems. This here describes the general process that you're going to use to solve the problems, but I'm going to go ahead and talk it out because I think an example problem is a little more helpful. But you can keep this slide as a reference in case you forget. So here we go. If Greg weighs 165 pounds, what is his body mass in kilograms? So this is a really good example of how we would use these conversion factors. We're starting off in one unit and we need to get it to a different unit. So figure out what we're starting with. So if you look at the problem, pretty much most of the time, whatever you're starting with is going to be the number in the problem. So here, 165 is the only number in that problem. That's what we're starting with, 165 pounds. And it wants to know what is the body mass in kilograms. So the whole point of this problem is to convert 165 pounds into kilograms. So we're starting with 165 pounds, we need to figure out kilograms, and so to get between pounds and kilograms, we need to have some conversion factor, some equality. So you can go and find that table that I gave you last time. It's also in your Chapter 2 lecture worksheet, and you can find how to get from pounds to kilograms. So this is the equality from that. 1 kilogram is equal to 2.205 pounds. So from that equality, we can write two different conversion factors. One that has pounds on the top and kilograms on the bottom, and the other one, which is exactly flipped, with kilograms on the top and pounds on the bottom. So I would always start off doing this. Figure out what you're starting with, what you need, an equality that will get you between them, and then write your two conversion factors. Then you can go about starting to solve the problem. Okay. So here we go. We're looking for kilograms and we're starting with pounds. This process of solving it this way is called dimensional analysis. And it's going to be really, really useful for pretty much everything in chemistry. In Chem 1, in Chem 20, in Chem 10, we always use this type of method to solve these problems. Now, you may hear me refer to it as train tracks, just by the way that it looks, and my high school chemistry teacher actually called it train tracks, and it stuck. So if you hear me refer to it as train tracks, I'm talking about this. Technically called dimensional analysis. You can pick which one you want to call it. But the way that the dimensional analysis works is that we are going to start with what we're starting with up in the top left. So we're starting with 165 pounds, and we are trying to convert it to kilograms. Okay, and so we need those two conversion factors that we did from the previous slide. So one of them had 2.205 pounds per 1 kilogram, and the other one was 1 kilogram per 2.205 pounds. Okay, so the way that this dimensional analysis works is that we're always going to cancel our units down and to the right. So if I have pounds up here on the top, my conversion factor that I'm going to use needs to have pounds on the bottom so that they will cancel out. So when we're looking, right, up here at the top, we need to use the one that has pounds on the bottom. Out of these two conversion factors, we're only ever going to use one of them. You just need to figure out which one. So since we have pounds on the top, we need pounds on the bottom. So that one is what we're going to use. Okay, so we're going to put a line, and then we'll put our 2.205 pounds on the bottom so that the pounds will cancel out with the pounds, and we'll put our 1 kilogram on the top. Remember that 1 kilogram is equal to 2.205 pounds. In this, in these train tracks and these dimensional analysis, when things are equal, they're always going to get stacked like that. So pounds is going to cancel pounds, so we can go ahead and cross those out. Now those units are gone, and the only unit we're left with is kilograms, which is what we were looking for. So that tells us we've done the problem correctly. When our unit in this top right is the unit that we were trying to find, then we're done. So now we can go about actually solving the problem mathematically. And the way that it works is that we are going to multiply all of the numbers on the top and divide by all of the numbers on the bottom. So the way this works, the way this works is we're going to do 165 times 1 divided by 2.205. So we have 165 times 1 divided by 2.205, and that will get us 74.8 kilograms. This is what I want you to remember. Always multiply the numbers on the top, divide by the numbers on the bottom. Okay? Everything on the top gets multiplied, everything on the bottom gets divided, and then you'll keep the unit that's in this last box. People always ask me, how many decimal points should I keep? And so for this class, I'm going to say just round everything to 2 decimal places. There are rules that dictate how we should actually round, and that goes with our significant figures. But for this class, we're going to say that's outside the scope of the class. You can worry about that if you go on and take Chem 20 and Chem 1. For this class, just round everything to 2 decimal places or fewer, just to be consistent. Okay, here's another one. How many seconds are in 7.5 minutes? Okay, so when we're thinking about solving these problems, this is the number in the problem, right? So this is what we're going to start with. And it's asking us to convert it to seconds. So we're going to start with 7.5 minutes and convert it to seconds. Our equality is going to be 1 minute is equal to 60 seconds. So we can write 2 different conversion factors from there. So we're going to say, okay, our 2 conversion factors are 1 minute per 60 seconds or 60 seconds per 1 minute, and we'll figure out which one we actually need. So we're looking for seconds, and we're starting with 7.5 minutes. So again, like I said last time, our units always have to cancel down and to the right. So if I have minutes up here, then I'm going to have minutes down on the bottom in my next train track. That means when we're looking at these 2 conversion factors that we're going to use this one on the right, 60 seconds per 1 minute, so that our minutes will cancel out. So we'll put, that should say, I'm sorry, my apologies, that should say 1 minute down there on the bottom. So 1 minute, and then our minutes will cancel out, right? And then our 60 seconds will go on the top. So minutes cancels what should be minutes. I'll go ahead and cancel it there. And then 60 seconds on the top. So again, once we get seconds here, which is what we were looking for, we know that we are done with the problem. And then we can actually go about doing the math. So we're going to multiply the numbers on the top, divide by the numbers on the bottom. So 7.5 minutes times 60 seconds per 1 minute, right? So 7.5 times 60 divided by 1 gets us 450 seconds. And again, just keep in mind, multiply the top, divide the bottom. Okay, go ahead and pause here and work on problems 10 through 18 on your lecture worksheet. This will get you lots of practice on doing conversion problems. Once you're done with those, unpause and come and finish the lecture. Okay, sometimes you will get to a scenario where you have to use more than one conversion factors. So this is an example where you're going to use 2 or more conversion factors. And this is actually really common in chemistry. Not so much in this class, but if you go on to higher levels of chemistry, this becomes really, really common, where you're going to convert from one unit to the next and then convert from that unit to the one you're actually looking for. So all that this requires is that you're going to need more conversion factors, more equalities. And you're just going to add like another track to your train tracks. And I'll show you how this works. So for example, how many seconds are in 3.2 hours? Okay, so we're starting with 3.2 hours, right? We found the number in the problem, and we're going to convert it to seconds. And so we have some equalities that we know. We know that 1 hour has 60 minutes, and every 1 minute has 60 seconds. So we have 2 different equalities that we're going to use to convert hours into seconds. So for each one of these equalities, we can write 2 different conversion factors. 1 hour per 60 minutes and 60 minutes per 1 hour. So that takes care of that equality. And then for the other one, we have 1 minute per 60 seconds, or 60 seconds per 1 minute. Okay, so that's our conversion factors. So now we can go about setting up the problem. We're trying to find seconds, and we're starting with hours. So again, when we're thinking about this, hours has to cancel hours. So remember, we're always going to cancel down and to the right. So that means this next track needs to have hours on the bottom. So if we look up here at our 4 conversion factors that we have, the only one that has hours on the bottom is this one. So that's got to be the one that we're going to use. So we're going to put 1 hour on the bottom and 60 minutes on the top. So then we can double check, hours cancel hours, and we're left with minutes. So minutes, though, is not what we are trying to find. We are trying to find seconds. So that means that we're not done with this train track. So we'll have to keep going. So now in our next track, we're going to cancel minutes down and to the right. But if you'll look, we have this one has minutes on the bottom, and this one has minutes on the bottom. So you have to think to yourself, which one am I actually going to use? Well, if I use this first one, I'm going to put minutes on the bottom, and then hours would go on the top. And so then our unit on the top right would not be seconds, which is not what we want. So we don't want to use that one. So we're going to use this one, because if we put minutes on the bottom, then seconds will end up on the top, which is what we're looking for here in the end. So we'll go ahead, 1 minute and 60 seconds. Minutes cancels minutes, and we're left with seconds on the top, which is what we were trying to find. So now, once your unit on the top right matches the unit you're looking for, you can go ahead and do your math. So we'll do 3.2 hours times 60 minutes times 60 seconds divided by 1 hour divided by 1 minute. And I want to point out here, you want to hit divide every time you have something on the bottom. Okay, so like divided by 1, because both of those ones are on the bottom. Sometimes people will get into this point and they'll be like divided by 1 times 1, because these are in the same track. Yeah, kind of. But don't do that, because your calculator will think if you put, it's not important with these ones, but it's important if you have real numbers. But if you put divided by 1 times 1, it thinks this 1 is up here, your calculator does. And so don't do that. Do divided by 1, divided by 1. I promise it will make your life lots easier, and that is one of the most common problems I see when people are doing these things wrong. So then you'll get your answer. And again, always multiply the top, divide the bottom. Go ahead and hop back to your lecture worksheet and work on problems 19 through 24.